Hi, and welcome to Allen High School's discussion of phase changes. Now, we're going to be looking next at a phase diagram. I think one of the most important parts of a phase diagram is the realization that phase changes can occur with altering the pressure as well as the temperature. Now, this diagram, actually some people like to call it a butt diagram. So you see a little bum cheek and a bum cheek, and there's the little plumber's crack, and then here's the gas. Okay, so we've got solid, liquid, gas. Now, what we want to do is evaluate what phases we have with different changes. So let me get rid of that arrow, and let's focus first on the lines. These lines here, these points in these lines, let's see if I can highlight them a little bit. On the line, we have both solid and liquid. So on that line, we have both solid going to liquid, and we have liquid going back to solid. And that's called an equilibrium, when both are present at the same time, and when the rates of each are equal. So when the rate of solid going to liquid is equal to the rate of liquid going to solid, we have equilibrium. So on the line, I have both solid and liquid. And if we look at this line boundary, on the line, I have equilibrium between my gas and my liquid. So this is a liquid-gas equilibrium. And then finally on this line, we have equilibrium between our solids. So we have a solid going to gas, gas going back to solid, equilibrium there on those lines. So an equilibrium is when the rate, let's just use one as an example, when the rate of melting is equal to the rate of freezing, we have an equilibrium. All right, so as we change temperatures and pressures, we'll end up with different states. And we will have what we call, when we change states, we call that a phase change. Both states are present on the line. The triple point's a special equilibrium. It's an equilibrium between gas and solid, solid and liquid and gas. So in the triple point, all three phases are in equilibrium and are present together. And I'll show you a nice little video clip of that when we get to school. So remind me to do that. Now let me get these arrows out of the way. That was from a botched video, actually. Okay, so now let's take a look at this phase diagram and analyze it. So we have a temperature of minus 100 degrees. So we're about right here. We're starting at minus 100 degrees, and we're going to go up to 100 atmospheres. So it's asking us to graph that particular point. At that point, I'm in the solid range. Remember, it's solid, liquid, gas. You might want to come up with some sort of a phrase, a mnemonic device that is S, L, and G to help you out with this. So it would be a solid at that point. Okay. So now, if we're at that solid, and this time that asked us to do the point. Now it's saying let's take this point. This is our state. And we're going to decrease the pressure. 100 atmospheres is crazy high. And we're going to decrease it until we hit 0.01 atmospheres. So now, if this were a map, it would say you are here. And in that process, we went from a solid to a gas. And you have to be able to tell me that that is sublimation. Okay? Now, for the part C, it says let's go back to part A, back to our starting point. And if we increase the temperature from minus 100 up to 20, so that's about right there. If you were a map, it'd say you are here. So what we did is we went from the solid to the liquid phase. Okay, and I read that, actually it said minus 20. So I read that as 20, but either way, minus 20 is right here. Sorry, I missed that little negative sign. But either way, we went from solid to liquid, and that is melting. Okay, so that's the temperature and pressure effects combined in a phase change. Now, for heating and cooling curves, we're going to watch an excellent video in class that I think does a fantastic job of describing these. So until then, this is signing off.